All right, so in this lesson, we're going to be talking about systems of equations using elimination. We're just going to be talking about the addition method first. So elimination is a method of solving a system of equations in which the equations are added together to eliminate one variable. So we're really going to be kind of setting the two equations on top of each other, and then we're simply just going to be like adding them like a normal addition problem. So we'll get into this and you'll see what I'm talking about. So step one, write the systems of equations so like terms are aligned. Step two, determine whether equations need to be multiplied by a constant so the two equations contain opposite terms. Add or subtract the equations to eliminate one variable. Solve the equation that results from step three for the variable that remains. In step 5, substitute the value from step 4 into either equation and solve this equation for the other variable. Okay, so there's a lot of same things from the substitution method. Let's go ahead and try the elimination method. We'll kind of see what's going on. So again, so step 1, it says write the system of equations so like terms are aligned. So you see how we have the x's on top of each other, the y's on top of each other, and we have the constants on top of each other here. So it's kind of like standard form. So we have, our ax plus by equals c. Then it says determine whether the equations need to be multiplied by constants so that the two equations contain opposite terms. Well, I know that the 7 and the 2, all right, if we add or subtract those, we're not going to get rid of anything. But notice right here we have a plus 4y and a minus 4y. Those two have common and opposite like terms. So it says determine whether equations need to be multiplied by a constant so the two equations contain opposite terms. These already do contain opposite terms. We have a positive 4y and a negative 4y, so they are opposite. Now it says add or subtract the equation to eliminate one variable. So what I'm going to do here is I'm just going to draw my line across on the bottom, and we're going to add this entire thing. So think of this as one giant addition problem. So this is a negative 2x and a negative 7x. We're going to end up with a negative 9x. Okay? Now, what happens right here is this is going to cancel. Okay? We have a positive 4y and a negative 4y, so it's just gone. And then right here, we're going to have 18. And so what we've done is we've just eliminated a variable, hence the phrase solving systems of equations using elimination. Okay? Now we divide by the coefficient, which is negative 9 on both sides, and we're left with x is equal to negative 2. Now we're not done yet, of course, because we only know our x value. So just pick one of the two equations, doesn't matter which one. So I'll use the top one. So I'm going to do negative 2 times x, which is negative 2, plus 4y is equal to 12. So now I need to multiply first. So I get positive 4 plus 4y is equal to 12. Subtract 4 on both sides, and we get 4y is equal to 8, and now we divide by our coefficient of 4, and so y is equal to 2. So my solution is going to be negative 2, 2. Okay, now I should be able to check that by plugging it into either equation up here and having it work. So again, there's still a decent amount of work to do here using the elimination method, but again, we're not graphing. And this is a good method to use when you have both equations in standard form and neither of them, or I should say all the variables actually have a coefficient. So you think about yesterday's or the day before's lesson where we were solving using substitution, and it was good to always solve for the one without a coefficient. Well, in this case, all of them have coefficients. So it would be a lot of work to use substitution method for this. So it's a little bit easier to use the elimination. So let's go ahead and try this again. Notice here we have our x's on top, our y's on top, and our constants here. We do have a negative 6 and a positive 6, so we're ready to go. Go ahead and add them together. This is going to be 0 out here. And if I have a positive 8 and a negative 4, I'm going to have a positive 4y, and I'm going to have a positive 4 as well. So 14 plus negative 10 is 4. So it's important to think about it like that. We have 8y plus negative 4y. So you always go over here and add, and then come back to whatever your number is. Now divide by 4 on both sides, and y is equal to 1. So now you got to plug it into one of these up here. I'm going ahead and plug it into this one because it is positive. It's plus 8y. So anyways, it doesn't matter which one. So negative 6x plus 8 times 1 is equal to 14. Now that's simple. That's just 8. So we have negative 6x plus 8 is equal to 14. Subtract your 8 on both sides. Again, negative 6x is equal to 6. And then divide by 6 on both sides. Excuse me, negative 6 on both sides. So the negatives cancel, the 6's cancel, x is equal to negative 1. So we have a solution of negative 1, 1, and that is where these two lines will intersect if you were going to graph them. All right, again, moving on here. Now, you see in this problem, we are not set up with like terms on top of each other. So what I'm going to do here is get the negative 5y, I need to get that over onto the left side. So I'm going to just write that whole thing over here. Negative 6x is equal to negative 5y minus 9. I'm going to add 5y to both sides. So I'm going to end up with 5y minus 6x is equal to negative 9. Okay, now that was my top equation. So I have my y value first, my x value second, and my constant. So I'm gonna go ahead and copy it over here. So we have 5y minus 6x is equal to negative 9. Now, this is a negative 5 and a positive 5, so let's go ahead and add them together. This is going to be zeroed out, and we're going to end up with a negative 2x is equal to 2. We divide both sides by negative 2, and x is going to be equal to negative 1. Okay, now what we need to do is just plug this value into our other equation. I can just put it in up here if I want. So 5y minus 6 times negative 1 equals negative 9. Now this is a negative 6 times a negative 1, so 5y plus 6 is equal to negative 9. I'll subtract 6 on both sides. So I end up with 5y is equal to negative 15, which works out nicely because 15 is divisible by 5. We divide by 5 on both sides, and we're going to get y is equal to negative 3. So our solution is negative 1, negative 3, and that's where these two lines will intersect if we were going to graph them. Okay, one final example here. Again, I do not have them set up in standard form, or I don't have like terms stacked on top of each other. What I see I need to do here is I need to move both equations around a little bit. So I'm going to rewrite the top one over here so I can work with it. So 10x minus y minus 8 equals 0. So I want to get rid of the negative 8. And so we can just kind of get it into standard form. So 10x minus y is equal to 8. Okay, so that one's good. Now we just got to get this equation also in that form. So let's subtract the 10x from both sides. And so we're going to get negative 10x plus 3y is equal to negative 4. Now, I'm looking at both of these. I have the x first, the y second, and the constant last. So let's go ahead and stack them on top of each other. I'm just going to bring this one over. So we'll go negative 10x plus 3y is equal to negative 4. All right, I'll draw my line. I'm going to add these two together because this is a 10 and this is a negative 10, so that's going to get zeroed out. I'm going to be left with 2y is equal to 4. And divide both sides by 2. And y is equal to 2. Okay, so now I need to plug in my value of 2 over here. It doesn't matter where. Since I have this equation right here on the bottom, I'm just going to go ahead and use that one. So negative 10x plus 3 times 2 is equal to negative 4. So negative 10x plus 6 is equal to negative 4. Subtract the 6 on both sides. And we get negative 10x is equal to negative 10. Divide by your negative 10. And we're going to be left with x is equal to 1. So our solution would be 1, 2. Again, that's the point where these two lines are going to intersect. Now, we didn't have any of these situations happen, where we have parallel lines or the same line for null solution or infinite solutions. But we could definitely have that happen here in these situations as well. So there you go, systems of equation using the elimination method.